Assalamu alaikum students. Today's your topic is about Fourier series. In Fourier series, we will first define periodic function. A function f of x is said to be periodic if there exists a number p is greater than 0 such that f times x plus p is equals to f of x for all x belonging to the domain of the definition. Mean if we adding any number within the domain of the function, then the function will remain throughout the domain. F times x plus p is equals to f of x. The least value of p is greater than 0 is called the period of the function f of x. For example, we can say that if we have any trigonometric function sine of x, then sine of x is equals to sine x plus 2 pi. It is equals to sine x plus 4 pi. It is equals to sine x plus 6 pi. Mean for all even multiple of pi, sine always gives you the same value. However, 2 pi is the least of the period 2 pi, 4 pi and 6 pi etc. Hence, sine of x is a periodic function with period 2 pi. Similarly, we can define the period of cos x. It is also 2 pi, and tangent x and cotangent x has the period of pi. And we have some notes about this topic. The first one note is if f1 of x and f2 of x have the same period p, then the function f of x is equals to c1 times f1 of x plus c2 times f2 of x also has the same period. But the period of the sum c1 sine of x plus c2 sine of 2x is 2 pi, which is in fact the least common multiple of 2 pi and pi. A constant function f is equals to c is also periodic and has any positive number as its period. Now we come to the Fourier series definition. In this we simply define the definition of a Fourier series. A trigonometric function, a trigonometric infinite series of the form a0 by 2 plus a1 cos x plus a2 cos 2x up to a of n cos nx plus b1 sin x plus b2 sin 2x up to bn sin nx plus. It can be written as a0 over 2 plus the series from 1 to infinity a of n cos nx plus bn sin nx corresponding to a function f of x is called its Fourier series, and the constants a of n and b of n are known as Fourier constant or coefficient. Now we will compute these Fourier coefficient with the help of a formula. We do not use here its proof because it is not necessary for you. You only simply take the values of a of n and b of n. If the series is a0 over 2 plus the series n equals to 1 up to infinity an cos nx plus bn sin nx is assumed integrable term by term. In the interval c is less than or equals to x and x is less than or equals to c plus 2 pi and has the sum f of x. If this whole sum is equal to f of x, then the coefficient an and bn are given by a of n is equal to 1 over pi c from the integral from c to 2c plus 2 pi f of x time cos of nx with respect to x, where n is from 0 to infinity, and b of n equals to 1 over pi c integral from c to c plus 2 pi f of x sin nx dx, and n is from 1 to 3. Now if we put n equal to 0 here, it will give you a naught value, which is 1 over pi integral from c to c plus 2 pi f of x dx. Here cos of 0 is 1. Now we have some corollaries about this computational theorem. Here, if when c is 0, the formula which is given in page number 2, it will become a naught is equals to 1 over pi from 0 to 2 pi f of x dx, and a of n equals to 1 over pi 0 to 2 pi f of x cos time nx with respect to x, and bn is equals to 1 over pi from 0 to 2 pi fx sin nx dx. Now corollary number 2 is when c equals to minus pi, the formula will become in place minus pi to pi. Minus pi to pi, your integral and limit will be changed here. Now we have an example, find the Fourier series representing the identity function. Now here f of x is equals to x and it is from the interval 0 to 2 pi, and sketch its graphs from x is equals to minus 4 pi to x equals to 4 pi. Now first one step is f of x is equals to x and it is equals to this Fourier series. Now we use the Euler formula, which is a naught equals to 1 over pi from 0 to 2 pi. It is given that the function is from 0 to 2 pi f of x dx. Now in place of f of x we will be put f of x equals to x. Now we solve this integral, it will give you 2 pi value. Now here a of n is 1 over pi from 0 to 2 pi f of x cos of nx dx. Now here we place f of x is equals to x. Now solving this integral, you can see we are solving this integral by parts. Now after solving this integral, we will have the value 0 because cos of 2 pi is equals to 0 and sine of 2 pi here it is equals to 0 and here it is equals to 1 and minus 1. So it will be 0 value. And now b of n value is from 0 to 2 pi f of x is equals to sine nx dx. Now simply putting f of x is equals to x, and after solving this with the help of by parts integral, we will have the value minus 2 over n. Now we will obtain the series x is equals to 2 pi over 2. It is a naught value, a naught divided by 2. Here we have a n value and here we have bn value. So in place of a and bn, we will substitute their values. Now we will have the Fourier series, which is the required Fourier series for the identity function. And now here we simply have x function. It is your simple straight line from the interval minus 4 pi to 4 pi. Now another example is obtain the Fourier series for e of x in the interval minus pi to pi. Here function is f of x is equals to e of x. It can be written as a Fourier series. Now here we will calculate a naught, an and bn. A naught is equals to 1 over pi, the function from minus pi to pi f of x dx. Now in place of f of x we will substitute e of x. After solving we will have this value. Now for a of n we will substitute this value here. It will be e of x cos nx dx. Now solving it by parts, we will obtain the value here. After solving this, it is a long procedure. You can see it. I have solved it in stepwise and it will be the last your value. And likewise, we will also calculate b of n. So we have a of n, b of n, a of naught, and we will substitute this value in the Fourier series. As student, we have no time for this detail, so I am simply skipping it. Now we have exercise 6.1. Question number 1 and 2 are simple. I have solved for you question number 3, in which we have stepwise function. F of x is equals to minus 1 from minus pi to 0. It is 0 for x is equals to 0 and 1 for x is from 0 to pi. Now we will write f of x as a Fourier series function. Now the Fourier coefficients are a naught 1 over pi minus pi to pi f of x dx. We will solve it in stepwise. Minus pi to 0 we have function minus 1. As you can see at the point 0 it is 0, so we will not mention it here. From minus pi to 0 it is minus 1 and from 0 to pi it is 1 value. Now after solving this equation we will have 0 value. And Same like a of n, we are also taking it into two integral. Minus pi to 0 it is minus 1, and from 0 to pi it is pi. Now after solving this, we will have, we also have here 0 value. And for b of n, we will also solve b of n from minus pi to 0 minus 1 times sine nx, and from 0 to pi 1 times sine nx. So after solving this, we will have two cases here, because cos of n pi is positive for even values and it is negative for odd values. So when n is odd, it will give you 0 value, and when n is even, it will give you 4 over n pi. So it is the solution of this equation. You only need to solve the Fourier coefficient in this exercise. You don't need to solve their continuity or discontinuity in this exercise. Okay students, thank you.